Okay, so continuing on from yesterday, we learned about complex numbers, meaning there's a real and an imaginary component, I meaning the imaginary number, okay? And we learned two forms of it. This was the rectangular form, rectangular. Remember, rectangular is identified by having X's and Y's or A's and B's. They're interchangeable, okay? Another way she calls another name for rectangular form, I've never heard it, but it's fine, standard form. So in the homework, she says, leave your answer in standard form, and so that just means the same as rectangular, okay? We also learned polar form of a complex number. There's that I in there, which makes it complex, and thetas and radii make it polar. She also calls it trigonometric form, so let's just say trig form, which that makes sense to me because it's got thetas in it. Trig is all about angles. Okay, we're going to do three examples. One product, one quotient, and one power. Okay, so product, quotient on the next page is taking them to a certain power. So what we're doing is multiplying first two complex numbers, multiplying together. So to multiply two complex numbers, we take the radii and we multiply them. Another word for radii is moduli. Modulus is singular for radius. Okay, so that's where that came from. And then argument, we add them together. Argument is your theta. I think we've seen that before. Like you'll see directions like make sure your theta is in radians, or your argument is in degrees or whatever. So you're going to multiply the radii and add the thetas. And you guys have seen another time in your math world where you have multiplication and addition mixed together. Just to help you memorize this. Whenever you're multiplying like bases, we add the exponents. So multiplication and, I meant to make that an addition. That's not a star. Addition. Multiplication and addition go together. Multiplication and addition. Then we have quotient. Quotient means divide. So we're going to divide our radii and then subtract our thetas. Just like another time in your life when you are dividing like bases, we subtract the exponents. And I always think of a fraction bar as like a big minus symbol too. Okay, so with division, we subtract. Okay, so let's do one of each of these right here. We're going to multiply and leave our answer in polar form. But for the sake of the notes, we're also going to do rectangular form on all three problems so we can review that. Because when you get to the homework, some of the questions say leave in polar form, some say write in rectangular form. And you can follow the directions in the homework exactly like it says. You don't have to do both, okay? I'm just doing it in the homework to review what we learned yesterday. Okay, so we're multiplying, and let's go ahead and start that. So z sub 1 times z sub 2, and I make my z's like that just because my z's look like 2s, so just so you know. So I'm going to take my radii and I'm going to multiply them together. So that's 2 times 3, which is 6. And then I'm going to show a little more work on this one than I will after this, but I'm going to take my angles, pi over 3 and pi over 4, and I'm going to add them. Pi over 3 plus pi over 4 plus I sine of the same two angles. Remember, theta is always going to be the same. So what's nice is you only have to do this math one time. Not common denominators, so let's find a common denominator. What would it be? 12. Okay, so your final answer would be 6 times cosine of 7 pi over 12 plus I sine of 7 pi over 12. So that's polar or trig form. Yes? Where did I get it? Yeah, I mean, you're going to see on the next one, we're going to skip that whole step. You don't really need to write it. Yeah, technically, okay, let me be all proper. You're right. It should be like that. Yeah. But you can skip that step. I'll show you. I'm just kind of showing a lot more work in this one. These are really easy, okay? They're just, if you can find common, this is probably the hardest part of math for some of us, right? Finding common denominators, adding fractions. Okay, now let's put it in rectangular form. We learned to do this yesterday. All we have to do is find cosine of 7 pi over 12 and sine of 7 pi over 12, and then we will distribute the 6 to it, okay? So let's do this in stages. So I don't know 7 pi over 12 is not one of my standard angles. It's on the unit circle. It's less than 2 pi, so I know it's on the unit circle. It's just not one of my memorized ones. So that's when I have to put it in the calculator. Okay, so sometimes we have to use our calculator, and we're not using inverse cosine because we're just finding cosine. We only use the inverse second button, also known as arc cosine, when we're trying to find an angle. So this is just cosine of 7 pi divided by 12, and I get negative 0.259, and then I, don't forget the I over there, it just tags along the whole problem, doesn't really do anything. When I do sine of 7 pi over 12 in my calculator, I'll get 0.970, and then I'm just going to distribute the 6. So I'm just multiplying by 6 in my calculator and rounding, okay? So my final answer would be negative 1.553 plus 5.800. So, like, where do you put the I? I mean, it just seems more natural to put it at the back of a number, right? Instead of I, 5 point whatever. But this is your rectangular form right here, okay? So when it comes time for the homework, just leave your answer in whichever one it tells you to. If it says polar form, you can just stop there, okay? All right, let's do division one. It's the same idea, except you're dividing and subtracting. Let's kind of like speed it up a little. We don't need to show a ton of work. I mean, of course you always can, but you don't have to. Okay, so for division, we divide the radii. Just like with multiplication, we multiply the radii. So 2 divided by 6 is 1/3. And then we're going to have cosine of something plus I sine of something. Now let's figure out what that something will be. We take our 2 thetas and we subtract them. Arlen Arbor, 9 pi over 16 minus 3 pi over 8. Remember, with division, we subtract. Remember, this looks like a big subtraction sign here. Common denominator would be 16. And always simplify your fraction if you can. That's not simplifiable, so I'm not gonna. But if you could, you definitely would want to. Okay? So there it is. There's polar form. Let's do rectangular form. So rectangular form, I'm going to need, all I need is cosine of this, sine of this, distribute the 1/3. Okay, so cosine of 3 pi over 6, cosine 3 pi over 6, 16, thank you. I'm like, why is it 0? Oh, it is 0 actually. Cosine of 3 pi over 16, okay? And then, actually, let's just go right to the answer. I mean, feel free to write it here. I'm going to skip right to the answer because I have this number on my screen. That's this right here. Then I just multiply it by 1/3 times, in parentheses, 1/3. Make sure you put a fraction in parentheses when you're multiplying. And I would get 0.277. And then sine of 3 pi over 16 times 1/3 will give you and that would be rectangular form, standard form. Okay. That's it for those two. Last one, very similar to it. I don't speak French, so I'm sure I'm mispronouncing this guy's name. But I think it's Demoivre. He is some important guy in math. I'm not really sure why he got his own little name and a whole page to do a problem that's this big, but we just go with it. So this Demoivre came up with a way of taking a rectangular equation, a complex number and raising it to a power. So if you raise to a power n, let's see what happens. You do your radius to that power and then multiply your thetas by that power. So n is whatever your power is. So this is raising this whole thing to the power 4. It's actually written wrong. It should actually have, Jordan, do you notice what it's missing? Yeah, it's the whole thing to the 4th power. But anyway, the formula says we do 2 to the 4th, so we're doing z proper. Z to the 4th power, right, taking z and raising it to the 4th power. Take your radius and raise it by 4. And then we're going to have cosine Jordan's making me want to be better about my stuff. Cosine of pi over 12 times 4 plus pi sine of pi over 12 times 4. Could you skip this step? Yes, I'm just showing it on this first one so you guys can understand where the numbers come from in case you miss it. So 2 to the 4th power is 16 times cosine of something plus I sine of something. That something, remember when you multiply fractions, we don't need a common denominator, but we do want to simplify our fractions. That's it. That is polar form. Rectangular form, we don't need a calculator for this one. We know pi over 3. Cosine of pi over 3 is 1/2, and sine of pi over 3 is square root of 3 over 2. And then distribute. Final answer, half of 16 is 8 plus 16 times the square root of 3 over 2 would be 8 square roots of 3 over 1. And you can put the I at the back, or you can put it in the front. Either one, okay? Just make sure, as I said yesterday, the lid, the roof, does not go over the eye. Okay, the eye is on the outside. Yes, and how I got this? Okay, so I'm doing 16 times square root of 3 over 2. Does that part make sense? Okay, so when you multiply fractions, you can just go straight across. And 16 over 2 is 8. Okay. Anybody else? No? All right. Page 165 and then 166. Again, I just gave you the odds to do. If you want to do more, of course you can. I'll start with you. Find the product, leave it in trig form, polar form. So product is multiply. Z times W equals 6 times 3 is 18. And then multiplication and addition go together. So I'm going to have cosine of something plus I sine of something. What is that something? Whatever I get when I add my two betas together. I would have a denominator of 36. What's wrong with this? Something feels wrong. Nothing's wrong. 13 over 36. 13 is a prime number. Can't be simplified with 36. So we get 13 pi over 36. 13 pi over 36. And it says trig form, you can just stop there.